Good afternoon, students. Welcome to the next session of our subject, that is concrete technology, material testing, and its evaluation. So, in our chapter number 4, we have started the discussion on the desired properties of the concrete. That is nothing but the strength, then permeability, then characteristic strength, compressive strength, then effect of water cement ratio, and admixture on the strength of the concrete. So that part we have covered in our previous session, and I think everybody has understood that particular part very well. So still, if you have any doubt regarding the same, you can unmute yourself and you can discuss with me, or you can just put it in the chat box. Okay, so the point we have started is nothing but the understanding the compressive strength, then understanding the tensile strength, flexural strength of the concrete, and what are the various parameters which are associated with the hardened concrete. So that part we have started with. So what are the factors which will affect the strength of a given concrete? Let us take the revision of our previous session in a very short, just in 2 to 3 minutes. So curing conditions like temperature or the humidity, then water cement ratio, then air content, aggregate characteristics, then cement type, its composition, then cement content, then strength, porosity relationship, that is permeability, and whatever the water which we are going to use it. So that is the point that we have discussed. I think the factors that we need to consider as far as strength is considered. Okay, strength and curing, how the relation is there. I think this chart also yesterday I have shown it to you. See, at the end of 28 days, your concrete is going to gain 100%
Sir,
strength.
graph is not visible.
Hello,
Graph visible nice.
graph is not visible. Just a minute. Just a minute. I will check. Oh, sorry. So the factors, I think now screen is visible, correct?
Yes.
So the factors which affects this strength we have discussed earlier, like curing conditions, then humidity, temperature, water is to cement ratio, then air content, cement type, its composition, the fineness, then cement content, strength, porosity relationship, and the water which we are going to use it. Strength and curing. If you see the graph, okay, how it is there. As we know, concrete is going to achieve the strength at the end of its 28 days. Okay, so how curing is going to affect as far as strength gaining is considered. Okay, how curing is affect as far as strength gaining is considered. So if you just see the first blue line, moist cured entire time. That means if your concrete is cured very well, okay, and completely if it is cured, then definitely it will give you the strength in the specified time, and the concrete is durable one. But if you are going to cure the concrete in somewhat dry and moist condition, or maybe semi dry condition, semi wet condition, then definitely it will take some time to gain the strength, as well as again we need to check the durability of that particular structure also. We need to check the strength of that particular concrete also in that case. Okay, so strength and curing, a simple graph is there for the understanding purpose. Just see the lines. See the first line, this particular line, moist cured entire time. That means concrete has been cured very nicely. It has been protected. It has been it remains in wet condition for a long time. Okay, so then second, as you can see, this particular dark red line, it is in air after 3 days, and in air entire time. See the strength achieving time. Okay, 100% strength. So if you just see the first line, see the pointer which I'm scrolling. If it is in air and it is not cured properly, strength achieved definitely less than 100. If it is in that particular condition, like you are in air for 3 days and then you are going to cure it, again it will take more time. It will take more time to gain the strength. If you take this next example, if it is remains in air for 7 days, okay, not cured properly, again it will take more time. If you see the graph, on y-axis we are having the strength, and on x-axis we are having the time. So If you are going to put it, if you are going to cure it very well, if you are going to protect it, definitely it is going to achieve the strength within the specified duration. And but if you are not going to cure it accurately, then definitely it will take some time to cure. Okay, and to gain the strength also. Then the factors, I think this part is again been repeated. I think the factors which are affecting the strength of the concrete, you can see the type of cement is there, then age of the paste, the first factor that everyone knows, the degree of the hydration. Okay, so for the degree of the hydration, we are going to consider the different parameters. Okay, like type of cement we are using, age of the paste, curing condition, at which condition we are going to cure our concrete or our cement paste, water is to cement ratio. Okay, then moisture content, porosity. Okay, all these are going to affect the strength. All these are going to affect the strength, or it may be other parameters related to the coarse aggregates. These are related with the cement, and these are related with the aggregates like surface characteristics, chemical composition, concentration, particle size, modulus of elasticity. Again, it will affect the strength. Okay, so basically we need to consider the different parameters which are associated with the cement as well as your fine and coarse aggregate. Okay, as far as strength gaining is considered. Durability, I think this part is there in your chapter number, um, the sixth chapter is there, that is based on the durability. So we'll have a detailed discussion about the durability and all that. Okay. Uh, so there you are going to cover up all these points like rebar mechanism, corrosion and all that. Okay. The point that I'm interested to discuss is nothing but the uh, just a minute. Yes, the strength which is going to be achieved by that particular concrete. Okay, as we know, concrete is strong in compression but weak in tension. So how can you assess the tensile strength of the concrete? So for that purpose, you can carry out two different tests, like flexure test is there, and second one is nothing but the split tensile test is there. Okay, split tensile test. Hmm? In the split tensile test, you will come to know the indirect tensile strength. It is also called as. Okay, you will come to know uh, the tensile strength of that particular concrete. Now, tensile strength means what? Sir, आम्ही concrete ला दोन्ही बाजूनी stretch करतोय. Whether it is possible, whether concrete is flexible? No, definitely not. ठीक है. Compressive strength is very important, but on the other hand, we need to check the tensile strength of that concrete also. So directly, it is difficult for us to determine the tensile strength. Okay, direct tensile strength, we are not going to measure it, but this is the test which is, or this is the test which is developed to assess the indirect tensile strength of that particular concrete. Okay, so tensile strength is one of the basic and important properties of the concrete. A knowledge of its value is required for the design of the structural elements. Its value is also used in the design of pre-stressed concrete structures, liquid retaining structures, roadways, runways, and the slab. Okay, as I told you, direct tensile strength of the concrete is difficult to determine. Definitely, it is very much difficult for us to determine the direct tensile strength of the concrete. But as I told you, we can measure the indirect tensile strength. Okay, we can measure the indirect tensile strength. मग हा experiment कसा perform करतात? What is that indirect tensile strength, or you also called it as the split tensile strength? The name given is split tensile strength. So this is a method of determining the tensile strength of the concrete. This is a method of determining the tensile strength of the concrete using a cylinder which splits across the vertical diameter, which splits across the vertical diameter. So it is an indirect method of testing the tensile strength of the concrete. As I told you, it is not possible for us to measure the direct tensile strength of the concrete. So for that purpose, we are going to take the indirect method into our consideration. And what is this indirect method of method of measurement of strength of concrete? We call it as the split tensile strength. Okay, so in split tensile strength, what we are going to do, we are going to determine the tensile strength of the concrete using the cylinder, which splits across the vertical diameter. Okay, so what is our how we are going to perform this particular test? Aim is nothing but to determine the split tensile strength of the given concrete. Apparatus are nothing but your weighing balance or the weights. Then your for where split tensile strength, we are having the cylinders. Okay, 3 cylinders having the diameter as 150 mm and the height of that cylinder is 300 mm. Okay, diameter is 150 and height is 300 mm. As you can see the diagram, so this is the cylinder which we are going to use. This is the cylinder in which concrete is been poured, and then this cylinder is cured for 3 days, 7 days, or 28 days. Okay, we have taken maybe almost 9 samples as like your concrete cubes. We have taken 9 cylinders. We have casted 9 cylinders for the same. The diameter of this cylinder is 150 mm and the height of that cylinder is 300 mm. And in this fashion, we are going to keep this cylinder in our what you call it as compression testing machine. And from the top, you are going to apply the load. So after the test, what will happen? The cylinder will split in the vertical direction like this. As you know, this is the diameter of the cylinder, 150 mm, and the cylinder will split in this direction. Just see the pointer which I'm scrolling. After application of the load, cylinder will split like this. ठीक आहे, दोन तुकडे होतात त्या सिलेंडरच्या मधनं. ठीक आहे. So how to calculate this particular split tensile strength? So we are having the standard formula to determine the split tensile strength. Split tensile strength T equals to 2P divided by pi LT or pi DL, where T is nothing but the split tensile strength. P is nothing but the maximum applied load indicated by testing machine in kilonewton. L is nothing but the length and D is nothing but the diameter. Okay, now if you just take one example, suppose P is 100 kilonewton, length you know it is 300 mm and diameter you know it is 150 mm. What is the split tensile strength of that particular concrete? Can you calculate it? If 100 kilonewton load is been applied, what is the split tensile strength? Please do the calculation and tell me.
Sir, 1 second, repeat, sir.
If maximum applied load is nothing but 100 kilonewton, that is P equals to 100 kilonewton, L is standard value, which is 300 mm always, and diameter is again standard. Okay, it is 150 mm. So what is the split tensile strength?
1.4 into 10 raised to minus 3.
1.4 into 10 raised to minus 3, or you can take it in Newton per mm square also. You will get some values like 1.4 MPa or 14 MPa likewise. Okay, so by using this standard formula, everyone please do remember this formula, because in your online examination, it may happen that some questions are asked, they are going to ask you on this particular point. Okay, split tensile strength of the concrete. व्हेरी सिंपल एक्सपेरिमेंट. काय केलेलं आहे रे आपण, परत एकदा सांगतो. आपण एक सिलेंडर घेतलेला आहे, त्या सिलेंडरचे डायमेन्शन्स काय आहेत रे, 150 mm बाय 300 mm. 150 mm त्याचा डायमीटर आहे आणि 300 mm त्या सिलेंडरची उंची आहे. ह्या सिलेंडर मध्ये तुम्ही कॉन्क्रीट पोर केलं. पोर कसं करणार आहे, 3 लेयर्स मध्ये पोर करतोय बाय गिव्हिंग 25 ब्लोज टू इच लेअर. आणि जसं आपण क्यूबचं क्युरिंग करतो तसंच 24 तास तो सिलेंडर तसंच ठेवायचा आहे. त्यानंतर ते सिलेंडर जे मोल्ड आहे त्या मोल्डच्या प्लेट्स बाजूला काढून आतमध्ये जे आपला सिलेंडर फॉर्म झालेला आहे कॉन्क्रीटचा सिलेंडर, तो सिलेंडर यू हॅव टू क्युर इट इन द वॉटर फॉर 7 to 28 days. ओके, जे काही तुमचं रिक्वायरमेंट असेल त्यानुसार तुम्ही त्याला क्युरिंग करणार आहात. बेसिकली 7 days आपण 3 सिलेंडर कास्ट करतो 7 days साठी, आणि 28 days साठी 3, असे 6 सिलेंडर कास्ट करतो. ठीक आहे. So you are going to cure this particular cylinders in the water for 28 days. ठीक आहे. आणि कास्ट तसं क्युरिंग झाल्यानंतर हा सिलेंडर लिफ्ट त्यात वॉटर टँक मधनं रिमूव्ह करायचा आहे, अँड यू कॅन प्लेस दॅट सिलेंडर इन कॉम्प्रेशन टेस्टिंग मशीन. सर्वांना कॉम्प्रेशन टेस्टिंग मशीन माहिती आहे. ठीक आहे. अँड देन यू आर गोइंग टू अप्लाय दी लोड. then you are going to apply the load. So how to calculate the split tensile strength? The formula is given in this particular PPT. Split tensile strength T equals to 2P divided by pi LD. 2P divided by pi LD, where P is nothing but the maximum applied load in kilonewton or Newton, whichever unit you want, you can take it. Then L is nothing but the length in meter or mm, and D is nothing but the diameter. Again, it is in meter or mm. Okay, split tensile strength. I think everybody has understood now. समजलाय split tensile strength काय करतोय आपण?
Yes.
Others, please do respond.
Yes, sir.
Okay. Chalo. Let's move towards the next test, that is nothing but the flexure test of the given concrete. Okay, flexural test of the given concrete. What is flexural strength? So flexural strength is nothing but the just a minute. It is also known as the modulus of rupture, bend strength, or fracture strength. A mechanical parameter for a brittle material is defined as material's ability to resist the deformation under the load. What is flexural strength? It is nothing but the ability of the concrete material to resist the deformation, under the load. Okay, as you can see here, you can see the deformation or deflection is there. Correct? एक बीम आहे आणि याचं असं डिफॉर्मेशन झालं. सो ॲबिलिटी टू रेजिस्ट द डिफॉर्मेशन, असं बेंड न होता. ठीक आहे. व्हॉट इज फ्लेक्चर? फ्लेक्चर या शब्दाचा अर्थ ते दिलेला आहे. द स्टेट ऑफ बिंग फ्लेक्स्ड. व्हॉट इज फ्लेक्चर? फ्लेक्चर इज नथिंग बट द स्टेट ऑफ बिंग फ्लेक्स्ड. फ्लेक्स बिंग म्हणजे काय? बिंग बेंड. असं बेंड झालंय बघा, हे स्ट्रक्चर तुम्ही बघू शकताय, जो की आपला बीम असणार आहे. ठीक आहे. लोड अप्लाय झाल्यामुळं तो बीम इट कॅन बेंड. Okay. Flexural strength. What is flexural strength? It is nothing but the ability of that concrete material to resist the deformation or whatever the part which is going to bend down. So the ability of the concrete material to resist the deformation under the application of load. As you can see, the load is acting. It may be simply supported load, it may be the point load, it may be the UVL, or it may be the UDL. Okay, so ability to deform the to resist the deformation under the load, you called it as the flexural strength. Okay, clear आहे? शब्दाची डेफिनेशन समजली सर्वांना? What is flexural strength now?
Yes, sir.
Okay, just a minute. Okay, so coming back to the discussion. Now I think you have understood what is the meaning of the word flexure. What is flexure? The state of being flexed. Flex means the state of being in bent position. So if you apply the load on any of the structure and if it bends down, okay, so whatever the deformation which was there, so ability to resist such bending, under the load, under the application of the load, is nothing but the flexural strength. So this flexural strength represents the highest stress experienced within the material at its moment of rupture. Okay, at its moment of rupture. Now, how to calculate this flexural strength? Now, if you see this formula which has been given, the flexural strength of the specimen, or as a modulus of rupture, it is calculated as Fa equals to PL divided by BD square. That formula is there. The flexural strength of the concrete member you can calculate by using the formula PL divided by BD square, where P is nothing but the load applied, L is nothing but the length of the specimen, then B is nothing but the width of the specimen, and D is nothing but the depth of the specimen. Okay, so by using this formula, you can determine the flexure strength of the concrete. Okay, now how to determine this? Let us see the picture of this particular. See, this is the beam that you have to cast. Okay, as you can see, this is the beam that you have casted. The size of the beam, it is 150 by 150 by 700 mm, or it is 100 by 100 by 500 mm. You can take any case, 150 by 150 by 7 mm or 100 by 100 by 500 mm for laboratory investigation. Okay. So if you are going to prepare the concrete beam of such size, you have to cure that particular concrete beam. काय करायचं जसं तुम्ही आता सांगितलं मी तुम्हाला कॉन्क्रीटचा जो आपला क्यूब आहे त्या क्यूब मध्ये तुम्ही कॉन्क्रिटिंग करताय आणि त्यानंतर त्याचं क्युरिंग करता. सिलेंडर सेम, सिलेंडर 150 mm डायमीटर होता, 300 mm त्याची हाईट होती, त्यामध्ये तुम्ही कॉन्क्रीट पोर केले, त्यानंतर त्याचं क्युरिंग केलं आणि त्यानंतर तो टेस्टिंग साठी घेतला. तसंच बीम साठी सुद्धा फ्लेक्झर स्ट्रेंथ साठी बेसिकली आपण बीम कास्ट करतो. या बीमची साईज किती असणार आहे? तर बीमची साईज असणार आहे 100 by 100 by 500 और 150 by 150 by 700. मग आता हे ज्या दोन साईज सांगितलेल्या आहेत, ऑन व्हॉट बेसिस वी आर गोइंग टू डिसाइड द साईज. See, if the span of the beam is more than 4 meter, okay, more than 6 meters, then you can take the higher value, the higher mold size, that is 150 by 150 by 700. Or if the span is less than 6 meters, 6 to 4 meters, then you can take the smaller size of that beam mold, that is 100 by 100 by 500 mm. काय करायचंय, जो काही आपला beam mold असणार आहे, you have to pour the concrete in that beam mold, and then you have to cure the concrete beam. That particular beam you have to cure it for 28 days. Okay, and for sample testing you have to cast at least 3 beams, at least 3 beams. Then you have to put this particular, you have to take this particular beam assembly in our universal testing machine or in flexural testing machine. If in your lab flexural testing machine is available, you can use that. In our case, in our concrete technology lab at our institute, we are having the flexural testing machine. Okay, so if you are interested to do some project on the beam, you can have that assembly with us. So we are going to whatever the beam that we have casted, we are going to test the we are going to carry out the test on flexural testing machine, or you can use universal testing machine. I hope everybody has seen the universal testing machine at your diploma college, and I think the subject may be at second year or third year. Okay, you have conducted one experiment on the steel reinforcement. So there you have seen this universal testing machine. So such assembly is there. As you can see, this is the first simple roller support. This is the second roller support. And on this roller support, the beam is rested. You have kept this beam on this roller support. And then at the center of this particular beam, the beam size is, suppose it may be 500 mm, it may be 700 mm. So at the center of this beam, you are going to apply the load. You are going to apply the load. So it is going to carry some kind of load. It may be 10 kilonewton load it has taken. It may be 100, it may be 150, it may be 200 kilonewton. So it has taken some load. And after that, at one point, it breaks down, as like you can see the second picture. It breaks down into the two pieces. Okay. So how to calculate the strength? The formula is with you. Flexural strength of the concrete equals to PL divided by BD square. What is P? P is nothing but the load which has been applied in Newton or kilonewton. L is nothing but the length of that beam sample. B is nothing but the width of that beam sample, and D is nothing but the depth. Okay. So you have to consider these dimensions. You have to note down the load which has been applied, at which the particular beam sample gets break down, and then by putting the values in the formula, you will get the flexural strength of the concrete. Okay. So there are two ways, as I told you in my previous session also, to check the flexural strength. First one, you called it as 3-point loading system. Okay, these are the two roller supports. Please see the pointer which I'm scrolling. These are the two roller supports or simple supports on which you are going to place your beam. This is the specimen of the beam. And exactly at the center, you are going to apply the load. Okay, so this is called as 3-point loading. Okay, and there is another way to calculate the flexural strength by using the 2-point loading system, where you are going to place the sample like this, and at intermediate distance, you are going to place your particular, you are going to apply the loads as like this. Okay, this is distance A, this is again distance A. Okay, here again, you can use such assembly also to derive the flexure strength of that particular concrete. So 3-point loading system or 4-point loading system, you can use it for your calculation purpose. Okay. Just a minute. Yes. So with that note, you can complete, or you can measure going to measure the flexure strength of the concrete. Okay, by putting the formula PL divided by BD square. Okay, PL divided by BD square. समझ ले flexure strength of the concrete. Everyone has understood? Understand?
Yes, sir.
Okay. So this is all about the remaining part of this particular chapter. Only one part is remained, that is concrete mixes for different strength as per the IS 456-2000. All rest parts of this particular chapter we have discussed in detail in our yesterday's, in our today's session. So let us take the last point of this chapter, that is concrete mixes for different strength as per IS 456-2000. Okay, so let me share my new screen. This is the IS 456-2000. The title is given Plain and Reinforced Concrete Code of Practice. Okay. See, as you can see in the presentation, this is the IS code that we are going to use, Plain and Reinforced Concrete Code of Practice. So here you will come to know what are the different grades of the concrete which are designated as per this particular IS code. Okay. So I will share that. So some additional information I will put it for your better understanding again. See, which IS codes we have to use for our cement. Okay, that part is there in the first half of this particular IS code. For OPC 43 grade, basically that we are using, it should be conforming to IS 8112. Okay, so if you are using the OPC 43 grade, it must conform to the properties which are mentioned in IS code 8112. Then if you are using OPC 53 grade, your properties of that particular cement is must conform with the IS 12269. For rapid hardening cement,